Okay, so here's the problem we left off on. The researchers from the Pew study interviewed two random samples. We have two groups. Both samples, the one taken in 2002 and the one taken in 2009, had 1,500 people. In 2002, 645 people expressed support for stem cell research. In 2009, 870 expressed support. Is the proportion of people in the 2002 group who supported stem cell research not equal to the proportion of people in 2009 who supported stem cell research at the 5% level? So the first bunch of problems we had was one group. It's supposed to be this percent. We think it's less than or greater than or not equal to that percent. The difference here is we have what? Two groups. Two groups. So because we have two groups, this one's going to be a two proportion test. We have two groups, two proportions, two fractions. As we do more, you're going to worry, oh, which one is it? Which one is it? And my job is to tell you it's obvious which one it is. Do I have one group or do I have two groups? How many groups do I have? Two groups. Do I have one fraction or do I have two fractions? Two fractions. It's literally screaming two proportions Z test. Two fractions, two groups, two proportions Z. Does that make sense? So as we do more and different types, don't stress out as much. Once you have the information, you look at what you have, right? So we have a 2002 group and we have a 2009 group. And we're trying to see if things changed. So in 2002, 645 out of 1,500, 43% believed in stem cell, supported stem cell research. But in 2009, 870 out of 1,500, 58% supported stem cell research. Okay? So here's the idea. Did things change? We always stop and we say, kind of what does our gut say? 43, 58. Do you think that the number's essentially the same, or do you think something's changed? Looks like something changed, right? If I got a 43 on a test and a 58 on a test, I'd probably study a little bit more. Something happened, right? There's a difference there. But we'll run the numbers to see. And when we have two groups, remember HO is always equal. HO is always equal. So when I have two groups, what am I going to say equal? The two groups. The proportion of people in 2002 who supported stem cell research is equal to the proportion of people in 2009 who supported stem cell research. And in the problem, they told us that it's not equal to. Okay? I could have easily done less than if that's what I wanted, but this one wanted not equal to, so we get to practice that. The proportion of people in 2002 who supported stem cell research is not equal to the proportion of people in 2009. So the question is, do I have enough evidence to say that they're not equal? That's the big question. Notice that the conditions are a little bit longer. Why are they a little bit longer? Two groups, right? We have to check the first group, and we have to check the second group. We also want to make sure that it has to all be random. The two groups have to be independent from each other. They have to be independent within the same group, which means I can't ask the same person twice. And as always, we always assume that the hypothesis is true. Just like when you go to court, you're proved to be innocent. You're innocent until proven guilty. Okay? Then we got a little confused. And the reason why we got a little confused is the formula asks for p hat, but I have two p hats. So the question is, which p hat do I use? The first group or the second group? And the answer is a combination. You add the numerators, you add the denominators. Even if the denominators were different, you still add them. Throw them all together. So which p hat do we use? The combined p hat. This, I'm really hoping you practice at home, because remember, if you type this in wrong, everything else is wrong. So I'm hoping you practice this. You found your SE. Once you find your SE, you take the first p hat minus the second p hat. Now I want to stop a second and talk about that minus 0. We know that if you subtract 0, nothing changes. So I didn't even write it, because I know it doesn't affect anything. But the question is, why is there a minus 0? Well, here's the answer. If the two groups were the same, what's the same minus the same thing? 0, right? 5 minus 5, 0. 3 minus 3, 0. 10 minus 10, 0. Does that make sense? So the whole minus 0 is saying there's no difference. There's no difference. When you subtract the two groups, you're trying to see if there is a difference compared to no difference. So the whole minus 0 is comparing it to no difference. No difference. Okay, that's the meaning of it. Then you get this z, and that's where I had you leave off for a second. And I wanted you to work on your own. Are we okay? So stop there for a minute. We've been doing a lot of z-scores ever since the first test. And we kind of get an idea of what's a good z-score, what's a weird z-score, what's unusual. What do we know about negative 8.20? That's unusual. That's off the charts. Something weird is going on. Remember doing that? So anytime it's really large, something's going on, and that should trigger, are these two things close to each other, or are these two things pretty far apart? Pretty far apart, because we got this large z. Does that make sense? So this is really important, right? If I had negative 1, you're like, oh, they're not that far away. Negative 8, oh my gosh, they're really far apart. Are we okay? So these are all triggers to lead you to think of something. Then, not equal to, we've only done one before, but remember not equal to checks less than, but I also have to go to the other side by putting a positive. But bottom line, that's a picture of my p-value. And looking at my p-value, does that look super large or super small? Super small. Now remember, we estimate. So anything off the chart, we call 0.99999. So if I subtract from 1, you get 0.0001. Now remember, that's not the actual. That's not the actual. That's an estimate. But it's crazy small. Crazy small. Are we okay? And for not equal to only, for not equal to only, for not equal to only, what do you have to do to the p-value? Double it. Why do we double it? Because there's two sides. Only for not equal to, only for not equal to, we double it. Are we okay? But remember, that's not the actual p-value. That's an estimate. Are we okay? That's an estimate. Because it's off the chart, we always use 0.9999. It could be 10 nines. Or in one of the cases we saw, it could be 34 nines. Right? Question? When it's not equal to. When it's not equal to, when we double.
But instead of doing like the decimal, like you're doing.
Yeah, you could have easily done the, if you did the percent one. And again, make sure you understand, it is the same. 0.02% is exactly the same as 0.0002. But remember, what's the nice thing that we can do? Check it in the calculator. We can check it in the calculator. So let's check all this in the calculator. This is new. We didn't do this last time. But you know, in your notes, I give you step by step how to do it. So you could have totally this weekend played with that and checked on it. Okay? So let's talk about how to check this in the calculator. Remember, always go to y equals. Make sure it's clean. Nothing in y1. Nothing in the plots are on. Always make sure you start with a clean calculator. And all of these are going to be the same way. We go to stacked, to the right for tests. But this time, we're not doing a 1 proportion z-test. This time, what are we doing? 2 proportion z-test, number 6. 2 proportion z-test, number 6. Are we okay? So we choose number 6. Then, you notice you have all these blanks. You have 4 blanks. The reason why you have 4 blanks is what does the calculator want? Fraction. But this time, how many fractions do we have? 2. So that's why we have 4 blanks. And just to be clear, there's your 2 fractions. 645 out of 1500, since we put that first, that goes first. 870 out of 1500. So again, how do you fill in the calculator? The first fraction. 645 out of 1500. Remember, you got to give the calculator what it wants. Here, 870 out of 1500. And are we doing not equal to, less than, or greater than? Not equal to. And then we go to draw. You can also do calculate. I'll do calculate next. And because it's a really large z-score, what does draw usually give me for the p-value? 0. And that's totally okay for the test to put 0. But we know that it's never 0. There's always a chance, but it's okay to put 0. We got negative 8.20. They got negative 8.22. Is that pretty close? Yeah. And this is a great way to check your work. Now, if you want to know what the exact p-value is, stat, test, go down to number 6, choose calculate. Choose calculate. If you choose calculate, be careful. What's the exact p-value? Yeah, see that negative 16? So how many zeros is it? 15 zeros. So your p-value is really 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then the 2. So is that a really small p-value? Yeah, super small.
Do you really want us to write it out?
You can do whatever you want. I don't mind this, I don't mind 0, I don't mind that on my test, right? But again, this is the exact p-value, and this is what it's really about. We're estimating here, but this is showing you it's really, really, really small. And especially on my stat lab, you can always do it by hand. You can always do it by hand, but my stat lab always wants the exact one, so use that one. And again, they're just gonna have it round to 0. But for the other ones, you can just use the calculator anytime they ask for P or Z. Okay, question?
So just to clarify, when it says e to the negative 16, it's basically moving the decimal place to 16 times the left.
Yeah, and because you have to go past the 2,
Okay.
it's
That's
15
one.
zeros. Yeah, good question. Now, alpha is what again? 0.05. So the question is, even though we're doing something new, 2 proportion z-test, it's all the same stuff. It's all the same stuff. Is your p-value smaller than alpha? Now, this, because remember we're keeping track, this is our 4th conclusion. I'm going to give you just a couple minutes, write down your conclusion. And it's nothing new. This is the 4th time. This is where you're going to find out, have I been copying for 4 times, or do I really understand it? And if you need that conclusion chart, get the conclusion chart, but write that conclusion. Do not wait for me. Do not leave it blank. You have to take charge and write it. So I'll give you just a couple minutes, because to be honest, I was hoping you do this part at home. Okay, about 1 more minute. Okay, now if you still need the conclusion part, no problem. But here's the bottom line. Is your p-value smaller than alpha? Absolutely. So we what? Reject HO. Now again, if you're copying that right now, you're not thinking, and that's horrible. You got to do it. You're just waiting for the answer to be put into your mouth. I move your jaw up and down so you can eat it, right? No. You got to do it. And I'm just trying to scare you now because we're going to do 15 of these. You can copy it 15 times, and you'll never know what you're doing until the test, right? So I'm trying to scare you. You didn't get the point. Now, when I say reject HO, what does that mean? HO is that the 2 things are equal. We reject that idea. I don't think that the 2 things are equal. Why? There is statistically significant evidence to reject HO. And what is my evidence? My evidence is that p-value. Okay, so that's sentence 1, sentence 2. And again, notice the pattern. Yes, we're rejecting HO because yes, there's enough evidence to reject HO. Yes, yes. We conclude the proportion of people in 2002 who support stem cell research. Now, again, remember the we conclude part. Where does the we conclude part come from? When we do the we conclude part, we always go back to HA. We always go back to HA. And when I go back to HA, I have a choice. I'm either going to put not equal to, or what's the other choice? I can't say equal. So it's either not different or, it's either not equal to or not different than. Are we okay? And if you're still shaky, which is okay, we're still learning this stuff, remember you have the hypothesis chart, right? So if we reject HO, I go with not equal to. If I fail to reject HO, I go with not different than. It depends what side you're on. Okay? So I'm going to literally put, we conclude the proportion of people in 2002 who support stem cell research is what? Not equal to the proportion of people in 2009 who support stem cell research. Okay? So again, all of this needs to make sense. We reject HO, which is the idea that they're equal. We reject it. Why do we reject it? Because there's enough evidence to reject it. Our p-value is so small, right? And then we can conclude, if I reject HO, I was right. The proportion of people in 2002 who support stem cell research is not equal to 2009. Are we okay? Yes, sir.
Can the 2002 and 2009 be switched?
Yes.
2009 first.
The only thing is got to be careful. The reason why I say be careful is be consistent. If 2000's in two front, it's always in front. If 2009's in front, it's always in front. Now, the reason why I say that is the perspective changes. Let's say 2002 is lower. I would say 2002 is lower than 2009. But if you put 2009 first, you'd have to say 2009 is, you see what I'm saying? So you just got to be careful. Both ways work, no problem. Are we okay? Now, we just proved what between 2002 and 2009? They're not equal. Perfect. They're not the same. What would you like to know? Well, not really the confidence. That's the next question. But what you want to know is, what are they? Is 2002 lower? Is 2002 higher? I don't know right now. All I know is that they're not equal to. Are we okay? So to answer that question, that's why we do the confidence interval. Now the formula is the same but a little different. The same but a little different. Normally it's p hat plus or minus z star times the SE. Are we okay? But because we have two groups, notice how the formula changes. P hat 1 minus p hat 2 plus or minus z star times the SE. So as I said before, yes, we'll be doing different things, but what changes are the little details. So see how, why do I have p hat 1 minus p hat 2 instead of just p hat? Because now I'm dealing with what?
Is it because you have two
groups?
Yes.
And that's basically it. I have two groups, and I'm trying to see if there's a difference.
Okay.
So again, the formula changes because the situation changes. So in this case, p hat 1, which is 0.43, minus p hat 2, which is 0.58, plus or minus, what's the z star for 95? 1.96, and then the SE from above, 0.0183. We put that in the calculator, always be careful, blah, blah, blah. Because again, if you don't practice this stuff, that also means you're not practicing how to type it in, which means your mistake could also be typing it in. And I'm trying to cover all the bases. That makes sense.
Can I get some clarification, please? For the Z-star?
Yep.
That's a fixed value, correct?
Yep.
Because it is the 95%.
Yep. It's tied to
Okay, so
95.
that's just something you just need to know.
And that's all from chapter 7, right?
Yeah.
So
Yeah, that little
68,
chart.
yeah, 68 Z-stars 1, 95 Z-stars 2 or 1.96 exactly. 99.7 is 3, and then there's those weird ones, like 90% is 1.645, but they come from that.
Okay.
And to be honest, the only Z-stars we're concerned with are 95, 90, and 99. Those are the 3 that we'll be working with. Are we okay? Now before we move on, oh my gosh, we got negatives. Ugh. Negatives, did we do something wrong? No, the question is, we have to figure out the meaning for the negatives. What do you think the negatives mean? Why did we get negatives? Which is correct. Why did we get negatives? 2002 compared to 2009. 2002 must be negatives. What does that mean? Oh, it's a question. Yeah, it's my question. Yeah, wow. So 2002 compared to 2009, I got negatives. 2002 must be smaller, lower, because that's what negatives mean. Does that make sense? So before I write this up, remember, we're comparing 2002 to 2009. I want to know if 2002 is lower or higher. That's what I want to know. What do the negatives imply? Lower. If they both are positive, that means 2002 is higher. If one was negative and one was positive, that means 2002 could be lower, or 2002 could be higher, which basically means they're the same problem. It could be lower, it could be higher. What's in the middle of a negative and a positive? 0. What does 0 mean? No difference. So again, those signs mean something. But before we move on, you want to use the calculator, right? So we did a 2 proportion z-test. How do you think I'm going to do an interval? So last time was A, now I'm going to go to what? B. And if you go to B, this is how nice your calculator is. It knows this is your next step. So what does the calculator do for you? It puts all the numbers in there for you. But be careful, how confident do you want to be? 95. Notice, when you do that, you get 2 negatives. 1854, 1859. 1146, 1141. Pretty darn close? Pretty darn close. Now, let's write in a sentence what this means. We are 95% confident the proportion of people in 2002 who support stem cell research is between 11.41%. Now, first of all, do you want someone to tell you 0.1141, or would you rather have someone say 11%? 11%. And why didn't they put 18 first? What makes more sense? 18 to 11 or 11 to 18? 11 to 18. So again, this is part of the interpretation. And I didn't put the negative. I didn't put the negative because I'm going to interpret the negative. 11.41% to 18.59%. What would be a good word to explain the negative? 2002 is what to 2009? Lower than the proportion of people in 2009 who support stem cell research. So let's stop there. If your hand is hurting, get used to it because this is our future, right? So we are 95% confident the proportion of people in 2002 who support stem cell research is between 11 to 18% lower than the proportion of people in 2009 who support stem cell research. Okay? So here's the deal. What did we prove? Is 2002 the same as 2009? No, they're different. They're different. They're different. How are they different? people's beliefs in 2002 are what? Lower by 11 to 18%. So is there a difference? Yeah. And what is the difference? 2002 is lower between 11 and 18%. Does that make sense? Now, as we understand that, and if you have questions, let me know. Let's play around with this. If they are both negative, that means 2002 is what? Lower than 2009. If they were both positive, that means 2002 is actually higher than 2009. Are we okay? If one was negative and one was positive, what that means is 2002 could be lower or it could be higher. So does that mean they're different? No. Does that make sense? And again, that's weird. It's different. It's a different way of thinking. That's what this is all about. That's what we're focusing on.
Now, how would we go about writing for that statement right there? How would we go about writing it if it were one positive?
Sure. I would write 11% lower to 18% higher. And literally, I know negative means lower, positive means higher. But instead of putting negative and positive, I put the words. And it's only because we're comparing two groups. We're comparing two groups that we have to do this. Are we okay? Take a step back. Look at the problem from start to finish. Start to finish. It is the same stuff, but the details are different. It is the same stuff, but the details are different. And remember, you don't have to memorize. You'll be allowed like something to help you remember all the formulas and stuff like that. Okay? But it's still HO, check the conditions, find the z-score, find the p-value, make the conclusion to the interval. That's the same with every single problem. The difference is the details. The difference is the details. And if you look on the next page, what do you have? Step by step with pictures written by me on how to do the calculator. We okay? So there's no excuse. The only thing that I can't do for you is practice and study at home. Okay? That's what I'm trying to scare you to do. So let's practice this. On the next page, I want you to read this one on your own, do the given on your own, and try to do the HO and HA on your own. Okay? So try to do this one on your own. seconds, wait for me. See how far you can take it. Okay, so let's see how we're doing. In fall of 2004, drug manufacturer Merck Pharmaceutical withdrew Vioxx, a drug that had been used for arthritis pain, from the market after a study revealed that its use was associated with increased risk of heart attacks. The experiment was placebo-controlled, randomized, and double-blind. Out of 1,287 people taking Vioxx, there were 47 heart attacks, and out of 1,299 taking the placebo, there were 25 heart attacks. Perform a hypothesis test to see whether those who took Vioxx have a greater rate of heart attack than those who have a placebo. Use a significance level of 0.01. So this time we're doing 0.01 for alpha. So it's harder to reject or easier to reject? Harder. You got to be under 1%. Good so far? So Do we have two groups? Yes. What are the two groups? Vioxx and placebo. So I'm going to put drug or Vioxx group and placebo. Again, you don't put the placebo group first or second, just be consistent. If you put the Vioxx group first, what's the fraction for the Vioxx group? And again, remember, we want the fraction because that's what the calculator wants. If you do 45 divided by 1287, that gives you 0.35. Then you put 49 and then it rounds. And then what's the fraction for the other group? 25 out of 1299. 25 out of 1299. That gives you 0.019. 3 4 decimal places. The first group has 1287. The second group has 1299. Do they have to be the same? No, they don't have to be the same. The only thing is if they're way off from each other, like one group had 1,287, another group had 7, we got a problem. But it also wouldn't pass your conditions later. Are we okay? What's alpha? 0.01. Questions so far? So we have two groups, two fractions. This is screaming that it's a two proportion z-test. Are we okay? Good so far? Now, there's a difference between plucking out numbers and actually knowing what this is. To catch that difference, can you write the sentence? That's what we're really going to find out if you know it or not. Well, we know that HO is always equals. So what group do you want to put first? P of the Vioxx equals P of the placebo. Now, in the problem, they told me we're looking for what? Greater than. And to be specific, which one is greater than? Good. So the Vioxx has to go first in order to use greater than. Now again, that's just plucking stuff out of the problem. The question is, what are we doing? What's the point in this? We're trying to say that if you take Vioxx, what's greater? Are we measuring arthritis? Are we measuring pain? Heart attacks. Heart attacks, heart attacks. So I got to make sure that this problem is focused on heart attacks. How do I know that? 45 out of 1287. 45 had what? Heart attacks. This isn't about arthritis pain. This is about heart attacks. So that's how I'm going to write it. The proportion of whom? People. Is this everybody? Yeah, I think it's just people taking vibes, right? So it's just people, right? Patients will be good. The proportion of people on Vioxx who what? Who had heart attacks is equal to the proportion of people on placebo who had heart attacks. Now that's a lot of writing, but we have to talk about the proportion of people on Vioxx who had a heart attack is equal to the proportion of people on placebo who had heart attacks. The proportion of people on Vioxx who had a heart attack is equal to the proportion of people on placebo who had heart attacks. Now, if you got that, fantastic. That means you understand what we're doing. Yep.
What if you put like and having? Because I put the proportion of people on Vioxx are having heart attacks.
Well, they had it though, so I can't count until they actually had it.
Okay.
But I wouldn't worry. Little word truth there. Okay. But here's the nice thing. Once you write HO, what's HA going to be? The same exact sentence, but we're going to throw in greater than. So the proportion of people on Vioxx who had heart attacks is greater than the proportion of people on placebo flu, and heart attacks. Now, I don't need to see anybody looking up at the board anymore. Nobody should be looking at the board. All you have to do is look at your own notes, and instead of equal to, you're changing it to what? Greater than. You don't have to look at the board. If you're looking at the board, that's one of those red flags that you're copying every word that I write. I don't want that. I want you to understand that HO is that the two groups are equal. HA, everything's the same, but instead of equal, we're going to put greater than. It's the same exact sentence. HO and HA are the same exact sentence. HO is equal to, HA is greater than. Good so far, good so far, good so far? Perfect. Then we check the conditions. And because there are two groups, this is longer. So the first N, 1287, times the first P, 0.035. Then 1287, 1 minus 0.035. Then 1299 times 0.0192. And 1299, 1 minus 0.0192. And I'll do the math for you, but remember, it's the N times the first P, N times 1 minus the first P, the second N times the second P, and then the second N, 1 minus the second. So don't just copy, make sure you know where everything is coming from. Make sure you know where everything is coming from. And I'll do the work for you, because that's just typing it in. And you notice it passes all of these, which means I asked enough people. My sample size is good. Okay, the other things we have to check, the groups have to be random, they're randomly selected, they have to be independent from each other. We didn't ask, mix the two groups. Within each sample, everybody's independent, no doubling up or anything, and we always assume the null hypothesis is true. Look at the first page, top to bottom. Any questions? First page, top to bottom. Any questions? You okay? Sure. All right, now you have one problem from before. I want you to move on to the next page, and I'll give you a little start. Which p-hat do we use, first or second? The combined p-hat. We have to take the two numerators, add them up, take the two denominators, add those up to find your p-hat. Then I want you to do this as much as you can. I'll give you about 5 minutes or so, just to give yourself a good head start, and then check it in the calculator. Check it in the calculator. want you to be working. I'm gonna kind of work it out up front as you're doing it, but only look up just if you want to just make sure you did it correctly. But I want you to do it on your own. Do it on your own. Don't copy, don't copy, don't copy. Only look up when you've done it. Only look up when you're done. Reseal. Yeah, don't worry too much about the wrap. Don't worry too much about the wrap. Oh, you gotta take it.
Oh, it's two.
you can start writing the conclusion, you can check it in the calculator, start doing all that. In about another minute, I'm gonna pick it on up. So check your work, see if you're kind of caught up with me in about a minute. I'm gonna start going over it. And if your rounding's a little different, no problem, no problem, no problem. Okay, so let's kind of go over it. Again, some of us are having little rounding things. Don't worry, as long as it's about the same number. Depends how many decimal places. But the more decimal places, the better. But your p hat will be this. Your SC will be about this. Plug it in, you get your Z. Once you have your Z, remember looking for greater than. Go to the table. Table tells you less than. As a decimal, as a percent. And again, if it's a little off, like you had 2.50 here, no worries. No worries, no worries. Let's just go to rounding. Okay? Now, what we're all feeling is, ooh, what if I rounded wrong? What if I did it wrong? That's a common feeling. How can I check if I'm right? The calculator. So I go to the calculator, stat, tests. I go down to number 6, and I put the two fractions in. The Vioxx group first, the placebo group second. This time we're doing greater than. Right? You can check all of it in the calculator. Check all of it in the calculator. If you go to draw, Z 2.46, I got 2.47. If you got 2.50, fantastic. I got 0.0068. The calculator got 0.0069. Fantastic. Are we okay? So it's a great way to check your work. Now, we're a little low on time, but again, this is stuff you got to do at home. Okay? The more we do in class, great. But you got to work on this all over again at home. Now, let's say we use the p-value from the calculator or the p-value from hand. They're essentially the same, either one, but there's your p-value, there's your alpha. Another problem that I have that I'm very worried about, you got to know your decimals. You have to know your decimals. You have to know your decimals. What do I mean by that? Some of you don't realize, is the p-value smaller or not smaller than alpha? Some of you are seeing, oh, 69 is bigger than 1. But again, you got to compare, right? So you need to be careful with your decimals. This is 1%. This is 0.69%. It's not even a full percent. So some of you may have the wrong conclusion because you don't know your decimals. Okay? Again, 2 zeros, 6, 9, 1, 0, 1. Okay, so be careful. Be careful. So let's do this one together because we're a little low on time. Is the p-value smaller than alpha? Yes. Yes. Know your decimals or percent, whatever you do. So if the p-value is smaller, we reject HO. Remember what HO was. HO is that the Vioxx group and the placebo group are the same. We reject the idea that they're the same. Why do we do that? There is statistically significant evidence to reject HO. And the evidences are really, really small p-values. So we reject HO. Again, this is our 5th conclusion. Are you copying it 5 times? Are you trying it 5 times? So we reject HO. There is statistically significant evidence to reject HO because our p-value is 0.0069. We conclude. Where do we get the conclusion from? HA. So I go back to HA. We conclude the proportion of people on Vioxx who had a heart attack, bless you, is what?
Thank you.
Now my choices are HA, greater than, or not greater than. Which one's it going to be? Greater than or not greater than? Greater than. Is greater than. Now if you're a little confused by that, go back to the conclusion chart. Is greater than, bless you, proportion of people on placebo who had heart attacks. Now, some of you are squinting and you're writing frantically. What did he write? What did he write? It looks so small. It looks so small. All I did was copy HA. Go back to your HA. Look at your HA. That's all I'm doing is copying HA. The proportion of people on Vioxx who had a heart attack is greater than the proportion of people on placebo who had heart attack. Don't squint. Don't stress. Look at your HA. Copy your HA. Questions?
It always says rate your p-value in a sentence. But
Yeah, we're going to skip that. It's really just, I'm just going to put instead of write, compare. Just compare your p-value.
Okay. I was just gonna, where it says compare p-value to the significant, that's the same idea, basically, just putting it together.
Yeah, all of this is the same thing.
Okay.
And just know that the main thing is if your p-value is small than alpha, smaller than alpha, something weird's going on, right? And that's kind of what I'm trying to drive home. So, we reject the idea that they're the same. And we're saying, if you take Vioxx, what will happen? You'll have, there's more of a chance, more of a chance of having a heart attack. Are we okay? So, let's go through our formula. P hat 1 minus P hat 2 plus or minus Z star times your SE. Now remember, we're saying it's more. Are we expecting 2 positives, 2 negatives, or a negative and positive? 2 positives. We're expecting 2 positives. More, greater, 2 positives. If it was lower, less than, I'd expect 2 negatives. If they were the same, I'd expect a 1 negative, 1 positive. See how, and again, it's weird thinking, but if you're like, oh, okay, that kind of makes sense. You just got to practice. So the first group, 0.035, minus the second group, 0.0192, plus or minus the Z star for 99. Remember, if you go back, we have a little chart for that in chapter 7. Yeah, it's 2.58, but it's 1 to 20. Remember what page that's on? Okay. 99%, the Z star is 2.58.
121.
121? Thank you. Okay, so that's where the 2.58 is coming from. The SE is coming from 0.0064 from above. And again, I'll work it out. So 0.035 minus 0.0192 minus 225.8, you gotta know where everything comes from. Does this come from the sky? You get this. Now, I want everyone to look up a second. Everyone look up a second. What is negative 7.12 e to the negative 4? 0.0007. So I'm going to put negative 0.0007. And then 0.0323. Now, we just had a good discussion saying how it better be two positives. We just had a good discussion saying that it better be two positives. What happened? My niece, when she was super little, she used to go, uh-oh. It's supposed to be two positives. What do we get? A negative. But here's the deal. How much of it is negative? How much? Is this 5%, 10%, 90%? This is barely negative. It's not 7%. It's not 0.7%. It's 0.07%. So look how much of it is negative. How much of it is negative? Like nothing. Sometimes it falls on the edge. Sometimes it falls on the edge. And if you actually round it, you would round that to 0. So should it be two positives? Yes. But sometimes it falls on the edge. Are you going to not reject it because of that little insignificant part that's negative? You see what I'm saying? So in reality, sometimes it may be a very, very, very small bit negative. We're still going to go ahead and say it's greater than. Are we okay? So for our explanation, I'll just round it to 0, because that's basically what it is. So we're going to say we are 99% confident the proportion of people on Vioxx who had heart attacks is between 0% to 3.2% higher, and I'll make it a little shorter, than placebo group. So, bottom line, if you take Vioxx, listen carefully to the question. If you take Vioxx, is your chance of having a heart attack higher? Yes. Yes. If you take Vioxx, is your chance of having a heart attack higher? Yes. Next question. By how much? By how much? 0 to 3%. Now, why is this important? Yes, your chance of having a heart attack goes up. Yes. How much? 0 to 3%. This is important because now you can make a decision. Let's say the government didn't pull it and you were able to buy it. Okay? Let's say you have massive pains every time you wake up. Joints hurt, everything hurts to walk all day, really, really bad. You took Vioxx, the whole thing went away. Now, nobody wants a heart attack, correct? But if that is a miracle drug for you, is it worth 0 to 3% chance of a heart attack?
Yeah.
Some yes, some no. Does that make sense? But see how you can make an informed decision? Now, same scenario. Let's say it's a 70 to 80% chance increase in having a heart attack. But do you see what I'm saying? You can now make an informed decision. Yes, there's a better chance of having a heart attack, but 0 to 3 versus 70 to 80. Does that make sense? Now, let's check it all in the calculator. So we go to stat, test. Which one do we go to for the interval? B, all the way down to B. B. Fractions are in there for us. Don't forget to change the confidence level to 99. Negative 7 e to the 4, 0.032, 0.032. Pretty darn close. Are we okay? Now, take a second. I'm going to guess your brains are full. You don't want to start chapter 9 today, do you? No. We're basically done with chapter 8, but do give me a minute of your time just to finish chapter 8. I want to look at this picture right here. This picture, this picture right here. The last thing I need to talk about in chapter 8, bless you. the last thing I need to talk about in chapter 8, there's a bunch of pictures that describe this, but this can be really confusing, especially when you do your My Stat Lab about it. But I'm going to explain it real briefly, 1 minute. Don't stress about this one. If you mess up your conclusion, we have a name for that. So for example, if my p-value is small, what are you supposed to do? Reject HO. But if you fail to reject HO, you made a mistake. Does that make sense? Same the other way. If your p-value is large and you reject it, you made a mistake. Are we okay? So messing up your conclusion has a name. So to keep this very simple, the two names are type 1 error and type 2 error, depending on which mistake you made. So this graphic, I think, is the easiest way to explain it. If you reject HO, it's because HO was false. Good job. But if you reject HO when you weren't supposed to, when HO is actually right, you made a mistake. That mistake is called a type 1 error. If you do not reject HO, if you fail to reject HO, don't reject it. It's because HO is true. Good job. You didn't reject it because it's right. Perfect. But if you fail to reject HO, when HO was wrong, you messed up. And what's that called? Type 2 error. So think of type 1 and type 2 error as if you mess up your conclusion. Are we okay? All right. So I'm going to stop.